Welcome to the deep dive. You know, the world of AI and enterprise technology, it's just exploding, isn't it?
It really is constantly changing.
Yeah, it feels like this huge waves of information. So how do you cut through all that noise? How do you find what really matters?
That's the challenge, definitely.
Well, that's exactly our mission today. For this deep dive, we're taking a bit of a unique angle.
Oh, yeah. What's that?
We're using a practice guide for the NS0-901 exam.
Ah, okay. Interesting lens.
Right, because it connects these core AI concepts with the real-world stuff, like NetApp storage solutions.
So it forces that practical connection.
Exactly. So we're going to unpack the really valuable nuggets from it, turn those exam-style questions into proper aha moments for you listening.
Making it tangible.
Yeah. The goal is a crystal clear understanding, core AI principles, but also how they actually, play out in real enterprise settings.
Sounds good. What are we covering?
Well, we'll start with the basics, like how AI learns, then move through how big companies manage their AI systems.
Okay. The operational side.
Right. And even get down to the nitty-gritty, like the high-performance storage that makes it all possible.
Foundation. Crucial stuff.
And you're here to connect those dots for us, right? Yeah. Help us see not just what, but why it all matters.
Absolutely. It's fascinating how something like an exam guide can actually map out that whole landscape, theory and practice.
It really forces you to think about applying it.
Exactly. Application is key.
Okay, let's dive in then. First, big insight. This is really foundational for AI. What's the real difference between supervised learning and unsupervised learning?
Ah, yes. This is fundamental. Absolutely core.
It feels like it gets right to the heart of how these models actually learn anything.
It really does. Because it changes everything, how you prep your data, what problems you can even solve.
Okay, so break it down for us. Supervised first.
Right. Supervised learning needs labeled input-output pairs. That's the key.
Labeled pairs. Like telling it the answer.
Pretty much. Think of teaching a kid fruits. You show a picture, say apple, show another, say orange. Explicit labels.
Got it.
The model learns by trying to predict the label, comparing its guess to the actual label you provided, and then, adjusting itself to get closer next time, minimizing the error.
Okay, that makes sense. So what about unsupervised then?
Well, unsupervised is the opposite, really. It works with unlabeled data.
No answers given.
Exactly. You don't tell the model what's right. Its job is just to find patterns, structures, relationships hidden in the data all by itself.
So like sorting things without instructions.
Yeah, that's a great way to put it. Like giving that kid a pile of mixed toys and saying, sort these how you think they fit together.
Yeah.
They find their own category.
That's a really clear analogy. So why does this distinction matter so much for you, the listener?
Well, knowing this helps you frame your problem immediately. If you have, say, historical sales data and you know the outcomes, which deals closed, that's labeled data, you're likely building a supervised model to predict future sales.
Okay, makes sense.
But if you're looking at maybe thousands of customer reviews and you want to find out what themes are emerging without deciding the themes beforehand.
Then you're exploring.
Right. You're leaning into unsupervised discovery. It guides your whole approach, data prep, the algorithms you choose. It's step one.
Okay, fundamental stuff covered. Now, let's say an AI is trained using one of those methods. Is that it? Is the job done?
Not even close. That's a common misconception.
Right. So our next insight gets into what happens after training when the AI is, out in the wild. The question from the source was, during the AI lifecycle, which phase involves evaluating performance and maybe retraining?
Yeah, it's definitely not set it and forget it. The critical phase here, the one the source is pointing to, is model monitoring.
Model monitoring.
Okay. So after you deploy your AI system into a live environment, you have to continuously track how it's doing. Its predictions, its overall performance under real-world conditions.
Why continuously?
Yeah.
Does it degrade?
It absolutely can. The data it sees in the real world might start to change over time. We call that data drift.
Data drift. Okay.
Or user behavior might change, or the whole environment shifts somehow. If the model's performance starts to slip or the new data looks really different from its training data,
then you need to step in.
Exactly. That triggers retraining or maybe just fine-tuning the model. You have to keep it accurate and reliable. That's crucial, especially if business operations depend on it.
So why does this insight really matter for you listening? What's the takeaway?
Well, imagine an AI that detects financial fraud.
Okay. Important job.
Very. Now, if you didn't monitor it constantly, new fraud techniques could pop up. Your model, trained on old patterns, would become useless pretty fast.
And that could cost a fortune.
Millions, potentially. Model monitoring is like your early warning system. It ensures the AI doesn't just work on day one, but keeps adapting, stays effective in the real changing world.
Okay, continuous adaptation.
Mhm.
It sounds complex, especially for big companies with lots of models.
Oh, it is. Managing all that is a huge task.
Which leads us perfectly to our next insight.
Hmm.
If you're a large enterprise, building, training, deploying maybe hundreds of AI models, how do you manage that scale?
Yeah, how do you orchestrate all that?
So the question we pulled was, which platform is commonly used in enterprises to automate and orchestrate those AI workflows, training, deployment, the whole life cycle?
Right, tackling that sheer scale and complexity. I mean, managing potentially thousands of models, it's a major challenge.
So what's the answer? What do they use?
The source we looked at points specifically to Amazon SageMaker.
SageMaker. Okay, I've heard of that. Part of AWS.
Exact. Amazon Web Services. It's
Yeah.
a fully managed service. That's the key bit, fully managed.
What does that mean in practice?
It means AWS handles a lot of the underlying infrastructure and setup. It gives data scientists and developers a whole suite of tools designed specifically for building, training, and deploying machine learning models at scale.
So it automates a lot of the tricky parts.
Yes, automating the workflows, managing the models through their life cycle. It significantly simplifies getting AI from, a developer's laptop into actual production use.
You mentioned at scale in AWS.
Yeah.
For organizations, maybe newer ones or those with a lot of existing on-premise gear, what kind of challenges pop up when they try to use something like SageMaker?
That's a really good question.
Or are there other ways they manage these workflows?
Well, SageMaker simplifies tons, but yeah, integrating it into existing data pipelines, dealing with company security rules, that can still be tricky.
Right, the integration part.
And things like data governance, keeping track of costs,
Mm-hmm.
making sure different teams can work together smoothly. Those are common hurdles.
And the alternatives.
For companies heavily invested on-prem or maybe using multiple clouds, you might see platforms like Kubernetes combined with MLOps tools, something like Kubeflow.
Okay.
They offer similar orchestration power, letting you manage those workflows, but they usually require more hands-on effort, more expertise to set up, manage, maintain.
So it's a trade-off then. Manage simplicity versus maybe more control, but more work.
Exactly. It's about balancing the managed service benefits with the need for granular control or integrating with existing systems.
That gives us a really important peek into the toolkit.
Yeah.
The strategic choices companies make to actually do AI at scale turns big ideas into something manageable.
It's the operational reality of MLOps.
Definitely. But of course, all this clever software, these complex models,
Yeah.
they need serious horsepower underneath.
Absolutely. The
Little-
hardware is critical.
So let's talk about that backbone, the infrastructure. Our next point zooms in on storage.
Mm-hmm.
Which NetApp storage solution is considered best for those really demanding, high-throughput, GPU-driven AI jobs?
Right, connecting this back. AI workloads, especially things like deep learning training, they are incredibly hungry for data, just consume massive amounts.
Need to feed the beast.
Exactly.
Yeah.
And they demand extreme performance from the storage system. So the solution highlighted in our source is NetApp's A series, specifically their all-flash FAS system.
A-series, all-flash FAS.
Yeah.
Okay, what makes them suitable?
They're engineered from the ground up for ultra-low latency and incredibly high IOPS.
IOPS.
Input-output operations per second. Basically, how many data read-write requests the system can handle every second. Super important.
Why is that so critical for GPUs?
Because GPUs chew through data incredibly fast. If the storage can't keep up, if it can't deliver data quickly enough.
The GPUs sit idle?
Precisely. Those expensive, powerful GPUs end up just waiting around for data. You need that ultra-fast access, high throughput for both training the models and for running them later inference, especially in demanding situations. It unlocks the GPU's potential.
That's a really strong point. It's not just the processor. It's getting the data to the processor fast enough.
It's the whole pipeline.
So the insight for you, our listener, it's understanding that specific infrastructure choices, like using all-flash arrays, are made to enable that cutting-edge AI performance. It's not just algorithms, it's ensuring the data flows at lightning speed.
Unlocking the full power of your compute.
Okay, final insight. We've covered learning, monitoring, orchestrating, storing. What about keeping the actual development process rigorous and repeatable?
Reproducibility. Hugely important in any scientific field, including AI development.
Right. Consistency, being able to repeat experiments.
Yeah.
That must be a challenge when you're iterating so fast with huge data sets.
It really is. So the question we explored from the source was, which technique helps address data versioning and ensure reproducibility in AI experiments?
Data versioning, like version control for code, but for data.
Kind of, yeah. And the answer highlighted is implementing data snapshots and clones.
Snapshots and clones. Tell us more.
So this practice lets you create consistent point-in-time copies of the exact data set you use for a specific training run or experiment.
Like freezing the data at that moment.
Exactly. And the really clever part, the reason snapshots and clones are so powerful is that they do this very efficiently. You don't usually need to duplicate the entire massive data set every time.
Save space and time.
Huge amounts. It's like having a perfect lightweight bookmark for your data state at that specific moment.
A perfect bookmark. I like that.
It means experiments can be precisely repeated later. You can verify results, track how changes affect outcomes. It brings that essential scientific rigor to AI R&D.
That makes sense for rigor. But you mentioned efficiency. How does using snapshots and clones help, say, a developer or data scientist in their everyday work, beyond just being scientifically sound?
Oh, it's massive for efficiency and just debugging.
Debugging. How?
Well, imagine an experiment goes wrong, gives you weird results.
Happens all the time, I bet.
Right. With snapshots, you can instantly roll back to the exact data state from a previous run that worked perfectly. It makes finding what changed, what broke things so much faster, speeds up troubleshooting like crazy.
I can see that. Pinpoint the change.
And it helps teams collaborate, too. Different people can work with the same baseline dataset version, run their own experiments using clones without messing up each other's work. They always know they can get back to that known good starting point.
So it avoids stepping on toes, digitally speaking.
Exactly. It's really a cornerstone practice for doing MLOps well. Robust, efficient development.
We really designed this deep dive to give you, listening, a concise but hopefully pretty thorough grasp of these key areas.
Turning that exam info into practical insights.
Exactly. Making it useful for your own projects, your own understanding.
And maybe, just to leave you with a final thought to chew on, as these AI models get even more complex, which they will,
Definitely.
and the sheer volume of data keeps exploding, which it absolutely is, just think, how will the ways we manage and version all that data and the actual infrastructure underneath it all, how will that need to keep evolving?
To meet those future demands.
Right. What new innovations might be just around the corner to make all these processes even more efficient, more reliable? How do we push the boundaries even further for what AI can actually do?